I was working through the problems that you and Hari discussed last week. Uh, so the circles around a circle ratio, I was tinkering with that. I thought maybe we can continue on that.
Yeah.
So I could work out the ratio for three circles with a small circle in the middle, 4 circles with a small circle in the middle. Hexagon, yes, the 6 circles one, yes, it's clear. There doesn't seem to be any pattern, and I had trouble working out the ratio for 5 circles. Then I tried 8 circles. I got square root of square root, so I stopped.
Okay. Yeah, I think even for 4 circles, it would be non-trivial, I think, right? So,
No, 4 circles is quite easy. It's like diagonal of a square, right? Diagonal of a square minus 1.
Oh, okay.
If the side is
yeah, yes, I can see. So, you have tried for 7?
No, seem too complicated. So,
Yeah.
I haven't got anything for pentagon itself.
So, what are you working on now?
Trying to look at the pentagon.
Okay.
So, I don't, wait, I'll just draw it and.
So, okay, one thing I can say for sure is the central circle will be smaller than the outer circles we are drawing.
Yes. So that crossover only happens at hexagon. So yes. Yeah.
Okay. So, okay. So, do you want me to like tell my way of thinking, or do you want to work independently for a while?
I want to work on it for a while.
Okay.
So one more thing. Last week you were talking about proofs based on symmetry.
Yeah.
So there the symmetry is just so it's based on observation, right? Like I don't have to prove that this is symmetric because this is equal to this. We can see that it's symmetric. Is that correct?
I mean, it's like I find it intuitive and kind of like good enough, but I don't see such questions or like such proofs accepted in like the maths textbook. So I don't know if it makes like a valid proof in an exam or like something like that. But I just can see intuitively that something is true. So like I remember like many years back, me and Shiv were like having this discussion. For example, like how do you know that in this pentagon, the angle bisector of the top vertex will be the perpendicular bisector of the opposite side, the base?
Yeah.
So, I mean, for me, it was just obvious, but I still don't have a proof for it. I'll just say it's symmetric, so it is like that.
Yeah, that's where I mean, that was the observation from which I was undoing this. Okay.
Yeah, so it is like, I will just accept it as symmetric. It's kind of, I don't know, self-evident, I would say. But yeah, I'm also aware that it doesn't make like a rigorous proof.
Okay. It doesn't make a rigorous proof. Why not?
Okay. First thing is like I'm saying it from this very conditioning that I have from school. I have never seen like any proof in school maths that makes you drop it. So that is one thing. So second thing is I am not able to make like the series of deductions which gives you this, like what leads to this, which leads to this, and so on. So I don't see the chain of implication. It's just that it is the same, So I can't think of anything that will imply that these two will be same. So what you're looking at is that small right triangle with angles 36 and 54, is it?
Correct, yeah. So this will be 36. So I took sine of this, which will give this by this. This is half. So from that I got the value of this as 0.85. So if this is 0.85, this again is half. So this inner circle will have 0.35.
You are taking the side of the polygon to be 1, is it?
Side of polygon to be 1, yeah.
Oh, okay.
So again, we have R1 is equal to half and R2 is 0.35. It's hard to find any patterns.
So what I was looking at was the whole triangle, that is the two right triangles put together.
Okay.
So effectively that 1/5 fraction of that pentagon, that triangle.
Got it.
So it will have angles. The top angle will be 72.
Correct.
And the bottom angles will be 54.
Correct.
So I will now use that formula A by sin A equal to B by sin B equal to C by sin C.
I'm not aware of this. I've forgotten trigonometry.
Oh, okay. So for any triangle, if you have ABC.
Okay.
Yeah, can you just draw the triangle?
No.
Sine angle A by A equal to sine of angle B by B.
Okay. Sine A by A is equal to sine B by B.
And equal to sine C by C also. So this is true for any triangle. And this will effectively solve the problem for all the polygons.
Wow. Right. So this follows from the same way of breaking this up into right angles and
I guess so. Yes.
for each
So yeah, I mean, I am just able to recall this formula. I don't know the proof, but yeah, I think we can prove that now if we need. So yeah, for the proof, I think we'll have to go through the same construction like what you're doing.
Yeah.
Yeah. So now if you are using this formula, it's like effectively you can find it for all polygons because you will know what the top central angle will be.
Yes.
And it will be isosceles, so we can find the other triangles. And
oh, beautiful. So this is nothing but the radius of the circumcircle, right?
Yes.
And that will hold true for all polygons. And now we have a nice way of finding this. So the ratio will be a ratio of the radius of this circle to this circle can now be expressed in terms of n for any general polygon. So we have so if C is the let me call it RC, radius of the circumcircle, will be sine of 180 minus 360 by n, and this whole thing divided by 2. So I can rewrite this as 90 minus 180 by n by sine of 360 by n. So now the radius of the inner circle, so let's call this R1 and R2. So R2, and we are trying to
yeah, I just want to make sure that is the side of the polygon is 1 or the radius is 1. The radius of the circle you're keeping as 1?
Side of the polygon is 1. Because I took so
Okay.
here sine A is this angle, and A I've taken as 1.
Okay, fine.
So
Yeah.
the side is 1. So this is the radius of the circumcircle. So from this I have to subtract half to get R2 is equal to RC minus half. RC minus half, yes. And R1 is half. So R1 by R2 will be this whole thing minus half by half. Okay. Not a very neat relationship. What are we missing? Is there some trigonometric property, because these are 90, 180, 360?
Yeah. So sine 90 minus theta will be cos theta, right? So
correct. Cos 180 by n.
And this will be 2 sine theta cos theta. You take theta to be 180 by n. So this will be sine 2 theta.
Correct.
So sine 2 theta is 2 sine theta cos theta.
Okay. This is all gone from my head. Okay. So 2 sine theta cos theta you're saying. So that will become 1 by sine theta then.
1 by 2 sine theta.
1 by 2 sine theta. Yes, 2 sine theta cos theta. So yeah. I'm just.
No, this looks neat. So
1 by 2 sine theta minus half. Half can be factored out, so it becomes 1 by sine theta minus 1, where theta is 180 by n. Okay.
Yeah, you had some other problem.
Yeah, I had this. I think Shiv had posted it on the group sometime back.
Yeah, I saw it. So now, what is the question? What is the next polygon? Like how many polygons?
The question he poses: how many such polygons exist?
The observation that I can make is that it's like the longest side is basically 2 power n.
Correct.
2 power 3 and 2 power 4.
Correct.
So I was kind of hoping to build the next one with 32 sides.
32, yeah. And there is one more thing, right? Like, so you start with 1, 2 has to take a turn. I mean, you have to take a turn for 2. Then you have to take a turn for 3. So essentially all the odd sides will have the same orientation, horizontal or vertical. And all the even sides will have the same orientation, horizontal or vertical.
Correct. Yes, I also observed this. So another observation that I have is, so now if you look at the total height of the left polygon for 8.
Yeah. It's 8. And so the width is 10.
So it's like we are splitting the numbers from 1 to 8 into 2 groups. All the odd numbers will be the vertical lines. All the even numbers are horizontal lines. Now within the odd numbers, you are splitting 2 numbers. You are splitting it into 2 groups so that their total is same.
Yes.
And the width and the height will have some relation.
width and height will have some relation. Okay, I don't see that yet. Length is?
For the first polygon, the total length is 10.
Correct.
And the height is 8.
Correct.
So there's a difference of 2.
Yeah. Here it is.
So
30,
here it will be
36.
36 cross 32.
Yeah. Difference is 4. Oh.
So now I was actually trying to find what will be the total height and the total width for the next polygon. I mean, the difference could be 6 or 8.
6 or 8, yeah.
So what I'm thinking is the perimeter of that polygon will be 1 plus 2 plus 3 up till 32.
Correct.
So that is going to be 32 into 33 by 2.
Correct.
So of which like that length plus breadth is going to be half of this. So 8 into 33. It is going to be the total of the length and the breadth.
Correct.
So now can we find the length and the breadth? Because we know that it will be half of the sum of all odd numbers, half of the sum of all even numbers.
Nice.
So yeah, I'm trying to find the total height and the total length.
By the fact that length will be, I mean, one orientation will be sum of all odd numbers, one orientation will be sum of all even numbers. That itself should give the relationship, right?
Yeah.
So the difference will be 16.
You are getting the difference between the like total breadth and total length. No, the 16 will be the difference between sum of all odd numbers and sum of all even numbers.
Oh, right. Yes. Yeah.
So basically, I'm getting the length and height to be 136 and 128.
136 and 128, is it? Okay, I haven't yet. Okay, 16 will be 2 to the power of, by 2. Right. Yeah, 128. So this will be 8 more. 136. Yes. Yeah.
So now it is a question of splitting all the odd numbers into 2 sets so that the sum is 136.
Same. Yeah.
But again, I think this is not straightforward.
Yeah. But does it answer the question how many such polygons exist? So now this looks like for every power of 2, we should be able to do this, right?
Yeah, I mean, we haven't built it. So yeah, my guess is it will work for every 2 power n. Yeah, but right now it is just a guess.
So for the odd numbered sides, so we have 1, 3, 5, 7, and so on, up to 25, 27, 29, 31. So we need 2 partitions, each adding up to 128. Now 128 is 4 32s. And we have this making of 32s. So there are 4 pair of numbers here, which add up to 32s. And 4 more pairs will be there here, because there are a total of 16 numbers. So we could use that to partition it. So 1, 3, 5, 7, 25, 27, 29, 31 would be in one direction. And all the rest will be in another. I mean, all these will be going up and the others will be going down. These will be going up.
Yeah, so this is what I'm also thinking, but this pattern doesn't work for the previous example. It works for the odd numbers. It doesn't work for the even numbers.
Oh. So can there be alternative solutions? I mean, did you try drawing it like this, or did you just observe that that pattern is not holding in this picture?
It's not holding in this picture, so I am trying to see if I can draw a different polygon with this pattern.
Okay.
So here, you are basically adding all the odd numbers from 1 to 15.
Right.
So here it should be 4 pairs of numbers which add up to 16. So that will be 1, 3, 13, 15 on one side and the others. So that's how it works. So this is fine.
Yeah.
Now, if you're looking for the even numbers,
correct.
We are effectively adding 2, 4, 6, 8 up till 16.
Correct.
So the total needs to be like 2 pairs of 18.
2 pairs of 18, yes.
So by following the same pattern, we would split as 2, 4, 14, 16 on one side and the remaining numbers 6, 8, 10, 12 on the other side. But here it's split in a different way.
Yeah.
So I'm actually trying to see if 2, 4, 14, 16 on one side can actually make a polygon. Is there some way we can draw it over here? Like, can we draw with a grid or something?
Yeah. Not bad.
So yeah, basically now for 16 itself, we are able to get another polygon.
Yeah. Okay, so when he said how many, he meant for this configuration, how many, I mean, for 16, how many polygons are possible, is it?
I mean, I was just thinking of it in like general terms. So now it looks like it will work for 2 power n. I mean, we don't have a proof, but seems to work.
Yes, yeah. So I mean, the steps that we followed are general enough to support this claim.
I mean, yeah, like intuitively it works, but we have to make sure it like doesn't cross over, and it's like, why should it exactly come at that? I mean, why is it not 1 or 2 off or something like that? I mean, our method,
it cannot be 1 or 2 off because it has to add up like this, right? So the way we started, the sum of all numbers from 1 to 32 and how that splits for the odd numbered sides and the even numbered sides, and how that in turn has to be partitioned, one going up, one going down, one going left, one going right. All that is fine. Are we missing something that might lead to crossing over? That is the only thing I'm not sure.
No, also, so basically what we did was we found another set of numbers which is adding up to the required length, the required height. Now it's like, will any set of consecutive numbers, if it adds up to the same thing, will it form a polygon? I mean, so here the original polygon that width is like 10, 12, 14. But ours is 8, 6, 8, 10, 12. Right?
Yeah.
So now it's like, if anything adds up to the required number, like 36 over here, will it necessarily form that polygon? So, And for example, does it so? Um, for example, 8, 14, 16 adds up to 36.
Yes.
8,
now 14, 16, no, 32. 8.
Okay, yeah. So say 6, 14, 16.
Adds up to 36. Yeah.
So now the difference is that these three numbers are not consecutive numbers, like the consecutive even numbers. But can I still form a polygon where 6, 14, 16 are on one side and the other numbers on the other side? I mean, it may or may not be possible.
So, all the conditions that we have identified so far are satisfied by this 6, 14, 16. Does it have to be that there should be equal number of down runs and up runs? No, right?
No, that is not there. But it's like, but in between we'll have all the odd numbers coming in, right? So yeah, can we try drawing this?
Yeah. So it worked out, but yeah, it took crossing.
But actually now I am thinking of it like a kind of a wire that is being coiled around. So you can kind of okay, the part which crosses over, you can effectively like swivel it to the other side. So that 6 you take it. So the 6, 2, 4, it should be all on the other side. So I think this is the same as the other thing we do, no?
Yeah, mirror image, that's it. Yes.
Okay. So have you heard of this problem called number sandwich?
Number sandwich, no.
Okay. So okay, maybe we'll discuss this problem in detail next week, because I see some random connections between that number sandwich problem and this problem. So okay, the question is this. I'll just like so.
Okay.
So I will just so just use the sequence 1, 2, 3, 1, 2, 3.
Okay.
Right. So now between the two ones, it is like it's like a sandwich. So between the two ones, there are two numbers. Between the two twos, there are two numbers. Between the two threes, there are three numbers. Right.
Two numbers. Between the two threes, there are again two numbers, 1, 2.
So now the challenge is to write the sequence in such a way that between two ones there is one number. Between the two twos, there are two numbers. Between two threes, there are three numbers.
Between the two threes, there should be three numbers. Okay.
No, you almost got it. Like you got the answer.
Is it?
Yeah.
1, 2, 1.
3, 2.
3, 2.
Now you just have to put a 3 somewhere.
Okay. Super.
Right. So now this is called a number sandwich. Between two twos, there are two numbers. Between two threes, like that. So now can you do it for 1 to 4, 2 pairs, 1 to 5, like that?
Oh, nice.
So I found this question from that Guardian column by Alex Bellos.
Okay.
So there he was like doing it for 1 to 9. I mean, the puzzle was like to solve it for 1 to 9, 3 pairs or something like that. I'm looking at the open problem for what numbers it's possible to form that polygon.
Okay. Yeah.
Yeah, I feel it will be something similar to the number sandwich problem. So next week maybe we'll just look at number sandwich, or this will continue.
Okay, yeah, sounds good.